Hi everyone, my name is Laura Hattar and I'm a senior graduating with my degree in Industrial and Operations Engineering and a minor in math. And I'm here today to talk about my honors capstone project, which is working with Michigan Medicine's Infectious Disease Department to document and create an efficient attending scheduling process. And my faculty advisor for this project was Professor Amy Cohn. So just a quick introduction into my project. There's just a couple quick questions I want to answer. So the first was how I got involved in the project. So I actually worked for the Center for Healthcare Engineering and Patient Safety back after the summer after my sophomore year of college, and I fell in love with it. I really like to be able to work in the healthcare field and just kind of see what went on behind the scenes and how complex it was to generate schedules and how engineering could improve those processes. So I had ties to CHEPS, which is how I came back to get involved into my honors capstone. And in terms of how I connected with my capstone advisor, it's pretty similar to the answer to the first question. Because I worked with CHEPS in the past, when I was thinking of my honors capstone, they were the first place I thought of and I was most interested in working with. So I emailed Amy Cohn and we were able to go back and forth and find a project that would work for my capstone. In terms of hurdles that were most difficult or least anticipated, I think an obvious one is COVID. While working on the schedule, a lot of communication is required, and sometimes it's hard to only be communicating through email. So that was a little troublesome, but we were able to have Zoom meetings and good communication back and forth to make the project run smoothly, which was awesome. So hopping into the actual introduction of the project, we can start off with what was the problem that we were trying to solve. So just in general, creating a year-round schedule by hand is prone to errors and alterations. Just imagine how hard it can be sometimes to set up a Zoom meeting between a few people. Now imagine having to do that every day of the week or every day of the year. And on top of that, changing an existing schedule by hand is really time consuming because it can easily lead to a domino effect. Once you need to swap one person around, sometimes that makes another person's schedule not feasible, and then you have to keep switching it up until you get something that works. And then if something comes up that doesn't work again, that whole process might iterate, and that is a lot. This in turn can add a lot of pressure and stress on those that are tasked with generating schedules. So in order to alleviate that, we wanted to use a linear program to mathematically model the requirements and constraints of a schedule, and then convert that into a code that generates feasible schedules in a fraction of the time needed to do so by hand. So what are we doing? We're collaborating with the Infectious Disease Department and CHEPS at Michigan Medicine to generate schedules for their attendings. So we did this by customizing an existing code to match the requirements and constraints of the attending schedule. And as of now, we have the schedule builder up and running, which accommodates many things, but I just list 3 of them here below to explain. The first is attending eligibility for different shifts. So for example, there's 6 services that attendings can work, and one of them is a transplant service, but only 7 out of the 32 attendings are actually allowed to work that. So it accommodates things like that. The next thing is time off requests. So if certain attendings want certain time periods off to go on vacation or go to conferences or prep for any other services, they're able to make those as well with the tool. And the last thing is spacing requirements between shifts. So as of now, we have a rule that at least one time period needs to be in between an attending working the same service back to back, just so they're not stuck doing the same thing over and over again. So some of the key tool inputs that we have, the first is just the list of attendings, all their last names. The second are the services. So for this schedule, there's 6 services. There are 4 at U of M, and then there's 1 at the Veterans Affairs Hospital. And the 5th one is actually also at U of M, but it's the transplant service. We also have all of the time periods listed. So ours go from 1A, 1B, all the way from 12A to 12B, and each time period is 2 weeks, so this does cover the full academic year, where the 1s start in July and the 12s end in June. We also have the activities, which are the service durations, and our rule is that each service just lasts 1 time period, which is 2 weeks. We also have service requirements per attending. So for example, some attendings may be required to work 4 shifts of transplant or things like that. So we have those rules worked in. We also have service eligibility per attending, which I talked on the last slide, and that just states which attendings are able to work the different services. And again, as I mentioned in the last slide, the spacing rules between services. And we also have time off requests and pre-assignments, and these are slightly different. So the time off request is a soft constraint. So these are requests that attendings make that they would like to have off, but they could come in and work. So when the tool looks at the time off requests, they try to accommodate them, but they might overwrite them if they have to in order to generate a feasible schedule. On the other hand, pre-assignments are a hard constraint. So you're able to pre-assign an attending to a certain service. So for example, you can pre-assign an attending to have time off for a certain time period. And when you make a pre-assignment, the tool cannot overwrite that. So if you pre-assign an attending to have a certain time period off, the tool has to accommodate that request no matter what. And if the schedule isn't feasible, it just comes back saying that the schedule isn't feasible instead of overwriting that request. So while we were working on the schedule, there were a few adjustments that we had to make. The first was that we didn't have enough attending shifts for the number of total shifts. So in order to calculate this, it is the number of time periods times the number of services. So for this schedule, we had 24 time periods and 6 services, meaning that we needed to have 144 assignments for a feasible schedule, and we only had 138. So when we communicated with the infectious disease department, we found where those missing shifts were with the attendings, and we're able to assign the correct attendings the extra shifts in order to hit 144 total assignments. We also had to add exemptions from holidays if any attending had worked that in the last 3 years. So that's only applied to Thanksgiving and Christmas, but we went back and pre-assigned those attendings time off for those time periods if they had worked holidays. And the last thing was that we tried to avoid front or back loading attending shifts. So for example, if an attending has to work 4 shifts total, we tried to assign them 2 shifts in the summer and fall and 2 shifts in the winter or spring, just so they're not working a bunch of shifts back to back, because each is 2 weeks and that does add up. So we're going to hop out of my PowerPoint here for a quick second just to kind of go through some of our input files. So when we come into our folder, we have our input, output, and raw data. So anything that we change in the tool is in our input folder. So I talk through all of these folders here. Anything with an exclamation point is what we kind of have things filled in for. And the rest of these files are just empty, so it doesn't affect the run of the tool. So we can do an example here with our pre-assignments input, which I opened in Excel. So what this has here are the attending names, and these are all just made up as a disclaimer, what they're being pre-assigned to. So this period means they're being pre-assigned time off, but if we look down here, there's some pre-assigned to the Veterans Affairs Hospital. And we also have the time period that the request is being made for. At the top here, we have the number of pre-assignments. This is because the tool will read that number of rows. So in this case, the tool will read up to 47 rows and then make sure that there's an end of column written in at the 48th row just to make sure it reads in everything. But I just wanted to do a quick example right here. So let's say that attending Wilson cannot work in April. So that means we have to assign Wilson the null service, which is this period, for time periods 10A and 10B. So if we wanted to make this change, we would add in Wilson here, and we would say that they cannot work in April, right? So we would assign them to null, which is time off, which is denoted by this period, and we would make sure to do that for 10A and 10B as that corresponds to the month of April. So once we have that, we can go back up to the top and change this 47 to a 49, so the code knows to read all the way down these 2 extra lines. And then we would save this and come back to our tool, where we would run our executable, which is right here. But since I'm not connected to a remote desktop, I'm unable to, but we would run this and it would give us an output. So I did run this and generate the output, which is found here. There's typically a lot of output files that are generated, but just to keep it simple, I just have this one, which is the schedule by attending report. So if we open this up, let's give it a quick second. It gives us the entire schedule for the whole year by attending, so all the attending names are here. We have the time periods, which we use as 1A, 1B to 12A, 12B, but I also have the months corresponding up here. And for example, if we want to look at attending Potter, we can see everything that they're assigned to for the whole year. And this way we can just double check that all requests are met, that any hard constraints are met, and that everything looks good before we send this off to the infectious disease department. So wrapping up here, what does this accomplish? Well, It improves the quality of schedules and the scheduling process for attendings. And this saves attendings time and stress, ultimately leading to better patient care, which is the overall goal of this project. And this also gives the potential for the same benefits to be achieved at institutions outside of Michigan medicine. This is because the scheduling tool will be available publicly. So again, it reaches that overarching goal of leading to better patient care. So that's all for my honors capstone. Thank you all so much for listening.